In this video, we're going to look at the trapezoid and how to find the area of a trapezoid. We'll look at a couple of ways, two ways to compute the area. Now, a trapezoid is a quadrilateral. It is four-sided polygon, and it has exactly two parallel sides. And these are called the bases. So this side here are parallel. Exactly two parallel sides. These are the bases, so we have base 1 and then base 2, and then the sides are called the legs. Now, if I take the midpoint of this side here on the left, the midpoint of this one over here, and draw this segment here, that's called the median. So again, this side, or this segment here and this segment are equal. And over here on this side, this little segment here, and this one over here, they're equal. So the median goes from the midpoint of one leg to the midpoint of the other one. And this one is, this segment right here, this line segment is parallel to the bases. And the median length of that segment is the average of the two bases. So if I call this side here base B1 and this one down here B2, B sub 2, then the median is B sub 1 plus B sub 2 over 2. So that's your median. And that's going to be important because one of the ways to find the area of the trapezoid is using this value here, this median. Now another thing to keep in mind that since we have B1 and B2 are parallel, the distance then, perpendicular distance from one to the other, say this one right here, perpendicular there, this length here is h, and that's the altitude. So if you're given the altitude of the trapezoid and you're given the value of the length of the two bases, you can easily find the area. Or in some cases, they might not give you the length of both bases, but they might give you the length of the median, and you can use that along with some other stuff you might have to find the area. Now the other thing to point out here is that if you have an isosceles trapezoid, so let's say this leg here is the same thing as this leg, say that they have the same measure, just like an isosceles triangle. Well, it turns out that the base angles are equal. So this angle right here and this angle right here would have the same measure, and say this angle here and this angle here would have the same measure. The total amount of the angles of the degrees would be 360. So if I add these up, they have to add up to 360. The base angles have the same value. So this one, and then up here, this one, and this one. So here are the formulas. Depending on what you're given, you can use one of these formulas. In some cases, you might have to use the Pythagorean theorem to find the additional information you need to find the area. You might not be given both bases, but you're given some information that allow you to find the other base. So if you have both bases and the altitude, then the area can be given by the sum of the two bases, B1 and B2, divided by 2, multiplied by the altitude. Now in the other case, you might be given the median. So if you're given the median, of course the median is just this right here. So if you're just given that value, then you know, okay, just multiply it by h, I got the area. So let's see how we can use these. Let's suppose on this one, I'm given a trapezoid, and they give you the median to be 12. And then say this distance from this base 1 to base 2 is 3. And they say, let's say that second base has a length of 17. Well, again, if I know the value, the length of the bases, it's 1/2 times the sum of the two. But I don't have that first base here. So in this case, we simply use this formula. Area then is going to equal to the altitude times, I'm using M for median, for the median. So in this case, altitude here is 3. So I can't use the 17 for this one here, so I use the median. And I guess it might be given this way, just to let you know that it's a median. Because remember, the median bisects the legs. So this tells me then that, okay, this point right here is the midpoint of this segment. This point here, because I have the marks, 2 marks there, saying these two segments are equal. That's what tells me that the value of 12 is the median. So all I gotta do is multiply this by 3 times 12. It's equal to 36. And that's square units. Square units. If they give you something like this and say, well, let's say this is 10 units, this is 12 units, and then they give you the altitude, 4. So in this case, you would use the other formula. Area then is going to equal to 1/2 base 1 plus base 2 times the altitude. So in this example here then, add up the two bases, 10 and 12 is 22. Altitude is 4. So 1/2 of 22 is 11. 11 times 4, 44 square units. Now let's suppose we have this. We have another trapezoid. Let's say this is 7 units. Say this space 13. And we want to find area. So now in this one, I'm given the two bases, base 1, base 2, but I'm not given the altitude here. Let's break this up this way. Say I drop a perpendicular here. Let me just do it this way, a little bit clearer. So let's suppose I drop a perpendicular from here to this side right here. And from here to this side over here. So I need to find the value of this. And we'll get some information. This angle right here is, say, 77 degrees. This angle right here, 77 degrees. And let's call this perpendicular. Again, this is 90 degrees. Create a perpendicular. 90 degrees. I'm going to call this H. That's going to be the altitude. Because on this one, I'm given the two bases, so I simply need the height or the altitude. Then I just add them up, multiply by half, and then multiply by the altitude. So again, this is 7 here, so this right in here has to be 7. This base here, this segment here has to match this one. So it's 7 from 13 here is going to give me 6. So this means this would have to be 3 over here. And this would have to be 3 over here. So I've got a triangle right here. So some cases you might have to use the Pythagorean theorem. In this case, we don't have enough information to use the Pythagorean theorem, but we can use trig. So I can use the tangent here and say tangent. So I'm looking at the triangle here. Tangent, with respect to this angle right here, is opposite over the adjacent. So tangent of the angle, in the case 77 degrees. And again, make sure your calculator is in degree mode. Sometimes you don't know it might be in radians and it's not going to come out. So the tangent is the opposite side, which in this case is the H, one of the legs of the triangle, over the adjacent side, which is the other leg of the triangle, which is this, 3. And then I multiply through by 3 here, solve it for H. And then say the H is equal, these will cancel here, so H will equal to 3 times tangent of 77 degrees. So in your calculator, you just key it in, 3, and then tangent of 77 degrees, hit enter, and this should give you 12. The two places, 0.99. You could actually round that out to 13 if you want, but I'm going to leave it 12.99. So that's H. So now I'm ready to compute the area. So this is going to be, I'm not given the median, so I don't use that formula. But I now have the value of each base, and I also have the altitude. So it's 1/2 the sum of the two bases. Remember the top base is 7, and the bottom base was given to be 13. So it's 7 plus 13. And then that's multiplied by the altitude, which we just found to be, again, 13. If you round it up, I'm going to leave it 12.99. So this is 7, and 13 is 20. Half of that is 10. Multiplied by 12.99. Multiplied by 10, just move the decimal over one place. That'll give me 129. So 129.9 square units. And like I said, depending on what they tell you, if you round it to the nearest whole number, 130. So the area would be 129.9 square units or 130 square units. Thanks for watching. Wish you next time.